Our names are Charles Pascale and Vishakh Kumar from Chem 1310, Section G11.
The reaction we'll be performing is the addition of zinc to hydrochloric acid. Our first reactant is zinc, a member of the boron family. Its atomic number is 30 and is located in period 4, group 12.
Our second reactant is hydrochloric acid, a strong protic acid. Its constituents are hydrogen and chlorine, chlorine being in group 17, period 3, and hydrogen being in group 1, period 1.
The balanced reaction is 1 mole of zinc will react with 2 moles of hydrochloric acid. This will give 1 mole of zinc chloride and 1 mole of hydrogen gas.
Alright, so we're going to take a clean 150 milliliter Erlenmeyer flask from the container shelf and add 15 milliliters of 6 molar hydrochloric acid from the material shelf to the Erlenmeyer flask.
We then place an airtight stopper on the Erlenmeyer flask to contain the gaseous products. In the virtual lab, we do this by making this a closed system. We now take a thermometer from the instrument shelf and connect it to the Erlenmeyer flask. This to show that the reaction is an exothermic reaction. We also connect a pressure gauge to measure the pressure.
We're then going to add 0.25 grams of zinc from the material shelf to the Erlenmeyer flask. As soon as we do this, we can start to see the reaction immediately from the bubbles and the evolution of gas. The temperature also increases, as does the pressure.
To shorten the video, we've edited out the cooling process. You can see how the solution has cooled down from 26.5 degrees Celsius to 21.5 degrees Celsius. We then use a syringe to collect the gaseous products, and we can see a reduction in the weight of the beaker. Before doing this, we first remove the instruments we've added to it, such as the thermometer and the pressure gauge. As we remove the gas using the syringe, we can see that the syringe fills up, and as we remove the syringe, there's a reduction in the weight. The volume in the syringe is 92.2 milliliters. Now, as we make the Erlenmeyer flask an open system, we see there is a further reduction in weight. This is because the syringe cannot remove all the gaseous hydrogen in the flask. We now conclude the experiment by clearing the workbench by dragging all the containers and instruments off the workbench and into the bin.
So our products that we get are zinc chloride, as you can see here, and hydrogen gas, which we took out with the syringe. We can see this reaction in real life. Here we see bubbles forming from the hydrogen gas, and the zinc is slowly being turned into zinc chloride.